Now we're going to be talking about arcs and angles. Now, a central angle, it's basically the angle in the center of the circle. The central angle, you guys notice I can cut it into various different angles. Now we arc is part of a circle. I can come over and say the arc VW. Now an arc, in this case, is going to have 70 degrees. The arcs have degrees. In this case, going to have 70 degrees because the arcs have the same degrees as the central angle. So the angle in the center. So you guys like, oh, can I say WX has 98 degrees? Yes, this arc has 98 degrees. And obviously the arc YX has 96 degrees. So the arc has the same degrees as the central angle. Now, one thing I want us to see really quick here, okay? How to read an arc. Sometimes I might use two letters, like for example, see number 9, I'm asking for the arc WZ. So sometimes I use two letters, but take a look at question number 10. I use three letters, okay? When I use two letters, like here, arc WZ, I want you to start from W to Z the shortest way possible. Okay, so we're gonna call that minor arc, basically the small angle, and they tend to be less than half of a circle. Like I said, I want you to start at W. I want you to start at W and finish at C the shortest way possible. So my arc will be this arc. Now, some people might say, well, Mr. Leonzo, I could have also gone from W. I could have gone this other way, all the way to C, but that's not the shortest way possible. So when I use two letters, I tell you where to start, where to end, the shortest way possible. So the arc WZ is that red one. Now, when I use three letters, that tends to be a major arc, so more than half of the circle. What I want you to do, the way you're going to read this, you're going to start at U, going to start at the point U, you're going to pass the point T, and you're going to continue all the way till you get to point R. So like I said, when we use three letters, more likely it's going to be more than half of the circle. So I tell you where to begin. So begin at U, go through the point T. So continue going through T all the way to R. So this major arc is going to look like this. Okay. That's how this thing's going to look like. So we know how to read arcs, okay? The minor arc, like I said, they tend to be less than half of a circle. The minor arc is using two letters. The major arc is using three letters, and that tends to be more than half of the circle. Please, I don't want to see when you guys are working this, I don't want you guys to think that the arc UT art is you go to U from U to T, and then you come back to R. That's not it, okay? Don't do that. Okay. So let's take a look at here. Question number 9. Let's work this out. We're going to work 9 through 14. Excuse me. So it says angle VPZ. Which one is that angle? So let's connect V with P and Z. So here's V. Here's P in the center and Z in this. Here, so we're talking about this angle. So angle VPZ and angle ZPY, that's this angle, are congruent. So they're telling us they're the same, but we kind of knew that from the graph because look, the arcs in the center, you notice how for 70 degrees, I only use one arc. These two that we were told that are equal, notice I use two arcs. And then for the 96, I used three arcs. And then for 98, I used four arcs. When the measurement was different, I used different marking. when the measurement was the same, I'm gonna use the same thing. Okay, do we know how big is angle VPZ? Not necessarily. So I'm just gonna call it X. I don't know what it is, so I'm gonna call it X. Okay, so VPC, we're gonna say, I don't know how big it is, so I'm gonna call it X. My pen just gave up, so I'm actually gonna write like this. Now ZPY, I'm also gonna call it X. Remember back in algebra, we learned that when we don't know the value of something, we replace it with a letter. So I call it X, each of them. Now find the measured of minor arc WZ. So remember, my minor arc, I want to go from W to Z the shortest way possible. I want to know how big is this arc? Well, I know that WV is 70. From W to V is 70. I don't know what's from V to C, so I have to solve for that. I'm gonna have to solve for that, but so I know this is 70 so far, and I know this is X. Because remember, the degrees of the arc is the same as the central angle. So 70 plus X. It would be nice if I knew what X was. So let me solve this. What else do we know from the inside? If I was to look at my angles on the inside, think about this. If I was to add all of them, because I'd see all my angles, 70 plus 98 plus 96 plus X gives me a circle. So I'm actually going to do that. To solve for X, I'm going to do that. I'm going to add everything. So I have what? X plus 70 plus 98 plus 96. I add everything. In this case, I'm going to let it equal to 360. 360 because it is a circle. So I'm going to solve for X first, and then I'm going to come back and answer my question here. I know to make it easy, I'm going to separate my sides with the equal sign. When it comes to letters, 1x plus 1x, I call that 2x. When it comes to just numbers, 70 plus 98 plus 96, uh, use a calculator if you need to. 70 plus 98 plus 96 happens to be 264. So let me write this as plus 264, and this is equal to 360. To get the 2x by itself, I want to get rid of this plus 264. I'm going to move it to the other side. However, I have to switch the sign. So instead of plus, I'm going to call this minus 264. So it's going to give me that 2x is equal to, now 360 minus 264 happens to be 96. If I divide by that number in front of the x, so in this case 2, that gives me 1x. 96 divided by 2 is 48. So x is equal to 48. I solve for x because I'm going to use it. Okay, so my answer is not 48. I was not solving for x here. I was trying to solve for x to be able to use it. So now I know this is 48. So let me change this to red. For my arc WZ, for me to solve this, I have to go 70 plus 48. So again, I wanted you to solve for x because then you were going to use it. Now, 70 plus 48 happens to be 118. So that's my answer, 118. Pretty cool. Let's take a look at another question. Let's take a look at number 10 here. Angle QPU and angle UPT are congruent. Okay, so which ones are those? QPU, that's X right here, and UPT. I don't know how big they are, so I'm going to call them X for right now. Find and measure the arc UTR. So let me highlight UTR. So from U to T, continue all the way to R. Seems like I need X, right? Because I know this part is X. I know this part is 94 degrees. And I know this part right here is 108. Again, the arc has the same degrees as the central angle. So I need to solve for X again. So let me solve for X. Let me add all my angles in the center. So I have letter-wise 1x plus 1x. So let me write that down. 1x plus 1x plus 94 plus 108 plus 51. And because that completes my circle, this is equal to 360. Letter-wise, 1x plus 1x, that is 2x. Number-wise, 94 plus 108 plus 51, that is 253. So let me write plus 253, and all of this is equal to 360. Again, I want to get rid of this 253. I'm going to move it to the other side, but I got to switch the signs. Instead of plus, let me write this as minus 253. So that's going to give me the 2x is equal to 360 minus 253 is 107. So I'm going to call this 107. Let me divide both sides by 2 to solve for x. 107 divided by 2 is 53.5. Decimals are numbers, so it's fine to have a decimal. So I'm going to say this x right here is 53.5. Okay, so for me to solve for my arc, like UTR, because that's what I was asked to solve. Had to add my numbers, right? So 53.5 plus 94 plus 108. So my answer in this case happens to be 255.5. Okay, let's do another one with a central angle. Let's take a look at here. Now the measurements were given to us a little different. So find the length of the major arc UTR. So starting at U, I'm gonna go through T all the way to R. So starting at U, past T, and then continue all the way to R. Okay. The angle QPU is congruent to angle UPT. So QPU is this angle, and UPT is this one. So I'm going to call it X each of them. The angle RPQ is 70 degrees. That's this one right here. The angle SPR is 97. And then the angle TPS is 51. Now here, we don't have an angle. It says the side, the measurement of the side, PR. PR, okay. This side right here is 16th. Okay. So first, let me solve for the angle that I'm missing. I'm going to read the instructions in a minute to see what I need to do. But let me solve for the X, the angle that I'm missing. I know if I add all the angles, I'm not going to add the side 16. I'm not going to use that just yet. I'm just going to look at the angles. So X plus X plus 70 plus 97 plus 51 is equal to 360. I added everything. It gave me a circle. Letter-wise, 1x plus 1x, that's 2x. Number-wise, 70 plus 97 plus 51, that is 218. This is equal to 360. My plus 218, let me move it to the other side as a minus 218. That gives me that 2x is equal to 360 minus 218. That's 142. Let me divide both sides by 2, so I get that x is equal to 71. Okay, so I know these angles are 71. Let me read the question again. So find the length of the major arc UTR. The length of the arc. Round to 2 decimal places is necessary, okay? Now, one thing that we know, I'm gonna say it is the length of the arc divided by the measurement of the arc. So if I knew the length of the arc and I divided by the angle, the measure of the arc gives me a ratio, right? Gives me a fraction. However, there's another fraction that I can come out with. I can come out with the the length of the circle, we're gonna call this. Some people call it circumference. I'm just gonna call it right now, length of the circle. Actually, I'm gonna call angle of circle. So yeah, let me change this in here. Measure instead of measured of arc, for us to not get confused, I'm gonna call it angle of arc. Okay, do we know what's the length of the arc? Well, not really, right? That's what we're asked for. So, oh, by the way, these two fractions are gonna equal each other. This is gonna give me two proportions. So they're gonna give me a proportion. Proportion means two fractions that are equal to each other. I don't know what's the length of the arc. That's what I'm solving. So let me call it x for right now. Now, I know the angle of the arc. For me to know the angle of the arc, I'm just going to add the angles of the arc. This is 71, this is 51, and this is 97. So 71 plus 51 plus 97. Well, that's 219, right? Let me see, 71 plus 51 plus 97. Yeah, it's 219. So the length of the arc divided by the angle of the arc. Now the length of the circle, okay? Now the whole length of the circle, isn't that what we call circumference? Remember some people call it 2 times radius times pi? Well, I knew the radius. Hold a minute. This is where this thing comes in. The radius is 16. So I'm gonna call this 32, well, 2 times 16 times pi. Now, one thing really quick. Let me share a calculator. Remember, I have to go 2 times 16 times pi. Now, if we write 2 times 16 times pi, it gives me an answer, right? So 2 times 16 times pi. Now, some people might write 2 times 16 times 3.14 because we were told back in the days that 3.14 is a good estimation for pi. And then we press enter. Now, one thing, if you guys use the pi symbol, it gives you an answer. If you guys use 3.14 for pi, it gives you a very close answer. Now, which one are you going to use? It really doesn't matter. Okay, I'm going to give you a choice. Use whichever one of these you want. Now, what I'm going to be doing is I'm going to be rounding to two decimal places. So if you were to use the pi symbol, 100.53. If you use 3.14, 100.48. Okay. Now, which one do you use? It doesn't matter. If you guys tell me, Mr. Jones, I want to use the pi symbol, good for you. Some of you say, well, I want to use the 3.14, good for you. In my case, when I create you guys' homework, I'm going to be using both. I'm going to tell Canvas to give you two possible answers. One, if you use the pi symbol, like I'm on a calculator using the pi symbol, and then your answer will be it. I want to get the same answer. And the other answer is if you use 3.14. So you have your choice. Okay, so let me come back to our question here. I'm gonna say the length of the circle is 100.53. I chose the pi symbol. Now the angle of the circle, isn't that 360? Circles are always 360. Cool. Now I can cross multiply it to solve for x. 360 times x is 360x. 219 times 100.53 gives me 22,016.07. Let me divide both sides by 360. By the way, some of my work, when I do my notes, sometimes I'm going to use the pi symbol. Sometimes I want to use 3.14. I'm going to be switching just to let you guys know that it really doesn't matter which one you choose. So I'm going to be switching intentionally. So you choose whichever one you want. Now here, I get 61.16. I rounded to two decimal places. Okay, so 61.16. Cool. Let's take a look at question number 12 now. The circle is centered on point P. Point Q, R, and S lie on the circumference. So yeah, I see P in the center. I see the points Q, R, and S on the circle. Measurement of angle QSR is 40 degrees. Find the measure of angle QPR. Now, QPR is this angle right here. I'm going to call it X right now. I did mention earlier that the central angle is equal to the angle of the arc. So the angle in the center is equal to the angle of the arc. So if this is X, I'm going to say this is also X. However, the angle on the circle, so not in the center, it's on the circle. You guys see this angle here? When you project it, this is 40 degrees. The angle on the circle, when you project it to the arc, is going to be twice as big. So it's going to be the angle of the arc times 2. Always, okay? So the angle of if the angle is in the center, it has the same angle as the arc, if the angle is in the center. Now, if the angle is touching the circumference, so it's touching the circle, the angle times 2 is the arc. Okay, so you guys might be like, okay, what does this have to do for X? Well, look at the arc. I said the arc is equal to x. And I said the arc is equal to 40 times 2. So if there's two measurements for the same thing, shouldn't I let them equal each other? I'm going to say x is equal to 40 times 2. So I'm going to say x is equal to 80. That's my arc. What I wanted us to go again is the arc has the same degrees as the angle in the center, but if the angle is on the circle, angle times 2 equals the arc. Okay, let me flip the page. Let me take a look at questions 13 and 14 now. The circle is centered on point P. Points D, E, and F lie on the circumference. If the measurement of angle DPE measures 80 degrees, so I'm just going to say, okay, this is the angle in the center, right? Because it's touching the circle. So I'm going to say this arc right here is 80 degrees because they're equal. Find the measure of angle DFE. Now, DFE, if I connect D with F and E, I'm talking about this angle. And so I know this arc right here, it is 2 times x, right? Because it's 2 times the angle on the arc. I mean, the 2 times the angle. But then I'm like, well, this arc is 2x and it's also 80. So I'm just going to let them equal each other. 2 times x equals 80. Divide by 2. So x must be 40. Remember that it has the same angle as the central angle, but not the same angle as if the angle is on the circle. Now let's take a look at number 14 here. Okay, so quadrilateral IJKL is inscribed in the circle. Now, what does inscribed means? That the corners touch the circle. That's really what it means, that the corners touch the circle. Angle I measures 97 degrees. Angle L is 67 degrees. Find the measure of angle J. Okay, so well, I'm going to use measurements here. If this angle L is 67 degrees, I'm going to say, if I project it, you see how I'm projecting my angle, it gives me this arc right here. And I'm going to say this arc right here happens to be 134 degrees. I just went 67 times 2. That's 134. Let me erase a couple of things here. If I needed to use the 97 degrees, I see 97 goes here. Right, I project my angle. It will tell me that this blue arc is 97 times 2. So I'm going to say the blue arc is 194. Now, what am I solving for here? Let's go with green. It says find the measure of angle J. This is angle J. And if I project it, it creates this arc. I am going to tell you there's some information here that is extra. That means I don't need to use it. Can I just say, if you guys take a look at this, can I just say that the arc ILK, you see the arc that I painted in yellow, plus the arc IK is equal to 360 because that's the whole circle. I can say that, right? You guys can see that the arc that I highlighted in yellow plus the arc that I highlighted in red, it creates a circle. I'm really just trying to create a circle. So the blue arc, I'm not going to use. So it's equal to a circle, so it's equal to 360. I don't know how big is the arc ILK, so I'm going to call it X for right now. I know the arc IK is 134. This is equal to 360. So let me, this plus 134, let me move it over as a minus 134. So I get that X is equal to 226. This yellow arc is 226. Not quite done yet. I'm ready. I was just solving for the arc that I could solve because I need to solve for angle J now. Let me call this angle J. I don't want to use X again. Let me use another letter. Let me use Y. I know 2 times Y is equal to 226. Because you see how this angle creates an arc. But remember I said 2 times the angle equals the arc. So 2 times the Y is equal to 226. So let me divide by 2. And that angle happens to be 113. What you guys are going to be doing is, you know that if that angle is on the circle, the arc that it creates is twice as much. So you guys are going to find which arcs do you guys need to be able to solve for the angles that you guys are working on. If you need help, feel free to reach out to me. I can always, I can always create different assignments, different questions. We can always work on Zoom. I can always show you guys how to do this work.